will be about responsible software craftsmanship, and I hope I'm going to give you something to think about on Sunday. My talk is definitely not meant to make you happy, because when we apply critical thinking and look at our craft, I think there is nothing we can be happy about. Partially, that's normal because our craft is so young. I think we are somehow a bit like the first builders. Yeah? Think 3,000, 4,000, 5,000 years ago. The first builders, when they have been building buildings, I think a lot of them have failed. Yeah, there's a joke about buildings in ancient Rome. He was a famous architect. He has built a lot of buildings, and some of them even have not collapsed. And our software is somehow pretty much like that. And I also feel that sometimes when people criticize this about our craft, others say, no, it's all fine. But I think then I get reminded of this guy. He is one of the most important medics of all times. He is the one who discovered hygiene. And he is the one who made sure that our mothers and our wives don't die when giving birth. He discovered that when you wash your hands as a doctor, that this reduces the mortality rate. And his work brought the mortality rate down from something between 10 and 35% to less than 1%. But his work was not accepted at the time when he lived, which is very sad. Although all the statistical material, all the evidence, all the data clearly said that he is right. It was the attitude of the people at that time that did not allow for the change to happen immediately. The people at the time, the medics at the time, highly distinguished people said, we are not dirty, we are clean by definition, we are from the upper class, we are educated, therefore we are clean. The microscopes were not yet there, germs and viruses were not yet known, but all what he found is, if you wash your hands, it helps. But people didn't want this to be true. So that's resistance, and as we've learned in an awesome talk before, you need perseverance to overcome it. Let's remind us what software development is, and I think that's one of the things that we are getting wrong in our daily work. And I think it's all four of them. But in our daily work, we are mostly on the lower side, and we are somewhere in between engineering and craft where I'm also not very happy about it. So that's a few things I'm going to talk about. But let's first talk about something else to relax a bit and free the mind. How many stars are there in the universe? Does anyone know? Infinite, that's not our current knowledge. We actually know a number, we know a figure. We don't know if it's correct, yeah? We might, as science progresses, we might find out new things. But we know that we can't count the stars in the sky because we don't see all of them. We have to count something else first. So how many stars are there? How big is the universe? If you want to know how many stars are there, we first have to know how many galaxies are there. What you see looks maybe like stars, but this is not stars, this is actually galaxies. And the number is huge. We have 100 billion galaxies in the visible universe, and each of these galaxies, per average, has 100 billion stars. And the size of the visible universe is approximately 13.8 billion light years, which means light, and you know that it travels extremely fast, takes 13.8 billion years from the oldest stars until it reaches Earth. That is really huge. I've given you another number, which is even bigger. Does anyone know what this number is? It's also quite a famous number. Not as famous as pi, obviously. This is the number of atoms in the human body, assuming an average weight of 70 kg. It's also quite interesting. It's interesting to know that the number of stars in the universe is so huge, but the number of atoms in the body is even bigger. That's a quote which I find very interesting. That's a German writer. He lived around the same time as Shakespeare. And that's something I want to remind us as software developers, that we should have ethics, that we should not do everything we are asked for. We should ask ourselves, whatever we are doing, is it good for society? I think that should be our first duty. And once we say, okay, it's good for society, the second duty should be, okay, is it also good for our employer? That's as a reminder, the Agile Manifesto. Who of you already knows the Agile Manifesto? Hands up. Oh, that's quite many. There's so many I don't even need to ask the other question. Those that know me know what the other question is. It is, how many of you would raise the hand if being asked to? Let's talk about CPU usage. I think that's something we get totally wrong. We couldn't get it more wrong, I think. This is a computer that celebrates its 30th anniversary this year. It's a Commodore Amiga 1000. It was released in 1985. Let's look at its specs. That's the user interface. You can see it already had a graphical user interface and a mouse. And it even had speech output. Let's look at the specs. It had a Motorola 68K CPU with 7 megahertz. It could display 4096 colors, and it had stereo audio, which with a little bit of programming, you could tweak it to be 14 bits at 56 kilohertz, which is near CD quality. CD is 16-bit at 44.1 kilohertz. It had a multitasking operating system. It had a graphical desktop called Workbench. It had speech output. You could run what you see is what you get, word processors on it. And it was very popular also because of its video editing capabilities. It had a PAL or NTSC compatible signal, and with GAN locks and digitizers, people were using it for video editing. And at that time, also a lot of TV stations were buying these machines. Let's compare it with a similar equipped machine today, a top machine today, which would be something with an AMD Centurion CPU running at 4.7 gigahertz. 8 cores, 64 bits as the bus, 8 GB of RAM instead of 256K. We would probably now have an SSD with 256 gigabytes. You didn't even have a hard disk on the Amiga. You had a floppy disk drive, and the size that the amount of data you could store on a floppy disk was 880K for that machine. The resolution today is much better, the colors are much better. But how much more powerful is a computer today than 30 years ago? It's obviously significantly more powerful. What are we doing with that CPU power? Are we utilizing it properly, or are we wasting it? And what happens when we waste it? I think we're not using it responsibly. So that's the first message I want to give you. A few more examples later on. I see some guys nodding. These are guys that I know, because I know what these guys are working on. They're working on computers which have like 8 to 20 kilobytes of RAM and 20 megahertz CPUs, and they run an operating system with a Java card virtual machine on it, and a transaction system. And the more sophisticated one even runs TCP/IP, HTTPS, encryption. You see, you don't need a lot of hardware to get things done. And the operating system is heavily reliable. It's a smart card operating system. They can't do what Microsoft does, ship it, and then fix it. That doesn't work with a smart card. Okay, let's have a small break. That's Han Solo and Chewie, the hyperjump. Faster than light travel. Dream of every scientist, every science fiction fan. First attempt would be just do it. The interesting thing is it doesn't work, at least not in an expected way. And it's even more interesting if you think about why it doesn't work. That's going to be totally mind-boggling when you think about it. It's because the speed of light is a constant, and in the four-dimensional space, everything moves at the speed of light. Us included. We are currently moving at the speed of light in the four-dimensional space. With time being the fourth dimension, and we either move spatially or in time. The faster you move in space, the slower you move in time. But the speed of light is constant and cannot be broken. Which means the more you approximate the speed of light, the slower time will pass for you. If you would be able to really reach the speed of light, time would stop for you. But the observer is not moving, so for the observer, time still is passing very quickly. Which is whatever we see in science fiction movies, with people traveling with light speed from one place to another, and then still having something like a universal time in the universe. That doesn't work. Okay, the next manifesto. Our profession somehow seems to be full of manifestos. In the beginning, actually, even I skipped one due to time. So, who knows the manifesto of software craftsmanship already? Hands up. Oh, that's not very many. Whom of you have been tired by my talk by now so much that they wouldn't raise their hands? Please raise hands. Okay. just one. So then we'll go through that because I think that's interesting. So almost everyone knew the Agile Manifesto. This manifesto was created by Robert C. Martin. I'm a big fan of him. I think he's one of the most important engineers of our times. And he says we shouldn't just get working software, we should also focus on well-crafted software. If the software just works, it will work for some time and then it will break in some way or the other. We need maintainable software. He says that actually it's more important to make code maintainable than to make code correct. That's a very interesting statement. But let's think about this for a moment. When we talk about correct code, we speak about code which satisfies the current needs of the current users. And that changes over the time. Whatever is suited for the business today will no longer be suited for the business tomorrow. In the first talk today from Brian, we've heard what happens to businesses if they do not adapt to new changes, to new requirements, to new technology. They go out of business. Companies that don't adapt to change, they will simply be thrown out of business. That's, for example, a threat that Microsoft is currently facing. Yeah, still one of the giants, a dinosaur in our industry, but Microsoft is actually facing extinction, and they know it. The reason why they're facing extinction is the cloud is removing the path dependency. It's not that we've been using Windows for 20 years because Windows is so nice. Actually, the more we know about computers, the more we usually hate it. The reason why we're using Windows is something else. It's path dependency. That's a term for marketing. It means that you're actually locked down onto a certain product path because you're dependent on certain things. If the company started in like 1990, it was a reasonable choice to buy a PC with Windows. And then you bought applications. And of course, you bought the applications for Windows. Then you upgraded the operating system. You had to choose Windows because your applications were running on Windows. You were updating your application. You had to choose the next version for Windows again because that was your operating system. You were locked in. The cloud changes this. Today, we don't bother what operating system we are running as long as there's a web browser. That is going to kill Microsoft's business. And that's why they're now entering the cloud. Could be almost too late, but the change of CEO was helping them a lot. Which brings us to the next point, change. Yeah? Not only responding to change. Yeah, you can respond to change all the time, but it doesn't help responding to change if you don't add value. So you have to make sure that whenever you respond to change, that you respond to change in a meaningful way that actually helps the business. The next thing, I don't need to talk a lot to you. That would be preaching to the choir. You're here, a community of professionals. If you wouldn't be interested in being part of a community of professionals, you would certainly not be here today. Let's look at decision making, and let's have a critical look at how we make decisions in our profession. Because I think that as software developers, we are technically minded people, and therefore we are trapped into thinking that we make our decisions as individuals and as organizations in very reasonable ways. And I'm going to shed light not on all, but on some of these aspects of decision-making to show that it's not at all that reasonable, especially not from a technical perspective. If it were, our world would be looking very, very different. Let's make another comparison. Let's look at the years 1979 to 1985, the era in which the PC was basically created. The invention was almost 10 years before that, but that was the time when the PC actually got from a self-building box with a hex keypad into machines that normal, ordinary people could buy. There were two competing CPUs, the Intel 8086 family and the Motorola 68000 family. And the Motorola 68000 was technically far superior over the Intel CPU. That's why almost everyone chose the Motorola 68000 CPU for their machines. We have some famous names there, like Apple or Sun Microsystems. Some of you might know HP Apollo workstations. That's the result of HP, Hewlett-Packard, buying Apollo computers. I think it was in 1989. We also have names like Atari and Commodore. They are now gone. They basically left the market the early 90s. But all of them have chosen the Motorola 68000 CPU. Why? If all manufacturers, except for one, have chosen the Motorola CPU, why do we have the Intel CPUs today? I think that's an interesting question to ask, especially given the information that the Motorola CPU was far superior and actually many times even cheaper. So how did Intel win? Let's look at the buying behavior of people on the market. When we buy something as highly sophisticated people, like we want to buy our next laptop, we want to buy our next phone, then we are in a market where there's usually a high brand differentiation. Yeah, we know how companies like Samsung, Apple, Motorola, HTC, how they compete with their brands on the market. And we have a high involvement. Yeah, we are using the products ourselves, and we are investing a lot of money into the product. That is where we have a complex buying behavior, where the decision-making process involves looking into a lot of details of our requirements, looking into the technical specifications of the products, making a match. But when you're in an organization and you need something, but you are not allowed to specify the product to be bought, you're only allowed to specify the requirements, the game changes drastically. Then we are still in a high involvement thing. Could be, for example, a version control system. Yeah, could be an email system. But the people making the decision have actually no clue about how to evaluate the technical specification. And then the buying behavior changes completely. The buying behavior is dissonance-reducing buying behavior. We also know this as no one ever got fired for buying IBM. And that's the reason why in some companies today you still find something like IBM Rational ClearCase as a version control system. From a technical perspective, that absolutely makes no sense. Since 10 years, it doesn't make any sense to use that product. It's only used because those people making the decisions are not the one with the requirements. So they do not really involve a complex buying behavior. They make it look like by having lots of meetings and so on, but in the end, they usually don't listen to the technical people. They just listen to the marketing guys of IBM, and they know they will never get fired for buying IBM. That's one of the reasons why Intel won the market, because they were with IBM. But that's not the only reason. We don't look at the right column because we are usually not looking at low involvement products. The right column would be like tissue paper. Yeah, that's not interesting for us. So that's a learning that I took from this about organizations and what cross-functional team in Agile actually means. It also means that the purchasing decision should be made by the team, not by someone else in the organization. I hope this is an interesting takeaway from this talk for you, especially if you're involved into how your organization structures and manages decision-making in purchasing. If you want to be truly agile, then make sure that also the purchasing decisions for whatever your team needs to get the job done is made by the team and not someone else in the organization. So we identified this point, but there's also a very interesting other point. And that point actually I find very enlightening. That's a point that makes me happy. Not because of the outcome, but because of the cause. So now here's some history lesson about the IBM PC. IBM actually never wanted to create a PC. But these other companies were. Yeah, like Apple and Tandy and Commodore, they all had these PCs. These new, very small computers that you could put under a desk or on a desk. So the customers of IBM started knocking at IBM's door and asking, can't you sell something like this to us as well? And IBM never believed in the success of the PC. They thought, it's a hype, it's not gonna work. They believed that computing should be terminals and a big, powerful machine. Sounded weird until like 5 years ago, but it's coming back. Today we call it cloud, and the terminal is the web browser. But for a long time, we had the PC, and IBM didn't believe in this, either because of being short-sighted or being too long-sighted. So they didn't care much about creating the PC. They just wanted something they could sell to make their immediate client, their immediate customers happy. So they did things they actually normally would never do. They did not write the operating system themselves, but instead they drove around to all these trade fairs where these nerds with their self-built PCs and these software guys were, and they found guys that would sell them an operating system. And one of these guys was Bill Gates. They did something else, which they also usually didn't do. They agreed to licensing terms that they would not obtain an exclusive license, something IBM normally never did, which gave Bill Gates the permission to sell the operating system to everyone else, whoever wants to buy it. This alone wouldn't have helped, because when you create something, a device like a personal computer, you own the copyright on the software and you own the patents on the design. So what happened to IBM's patents to the IBM PC? The simple answer is they were not allowed to use it because at that time they were considered a monopoly and they had an antitrust case from the US government against them, which disallowed them from entering more market segments in the computer market unless they free their patents. So they created the IBM PC, they had patents, but they were not allowed to sue anyone who would build a clone of it. And then these other companies said, if IBM creates a PC and we can build it, we'll build it. But there's a problem with the software. Oh, we can buy it from Microsoft. They already have it. The only remaining part that these companies had to take care of was the BIOS. The BIOS was from IBM, and IBM had the copyright, so they had to clone the BIOS. And then IBM-compatible PC was created, and that actually made the IBM PC also very successful. And in some way, this is a success story of open source, at least in the hardware. If the hardware were not forcibly open source, because IBM could have used the patents, then everyone who would have tried to create an IBM clone would have been sued and driven out of the market. So that made a change to the situation, which means the Intel CPU, because IBM was using it, everyone who created an IBM-compatible PC would also be using the Intel CPU. As the outcome of this, the worst CPU was used, and that made Intel win. And I think it's very important for us to understand that despite we are trying to be a discipline which makes technical decisions for purchasing or anything, we are far more driven by money than anything else. We have to be aware of that. Whether or not you find it good, that everyone has to judge on themselves. But I want to create the awareness for that. So, the two lessons are Intel won because of the buying behavior, and Intel won because of the open source hardware. Now, questions that you can ask yourself: was Intel's victory good for the market? I think that's very opinionated. My opinion is it was not good for the market. Did the industry make reasonable decisions? What are the consequences? What did the competition do wrong? I think that's the most important question. What did the competition do wrong? If you look at the right side, every single of these companies created a computer with the same CPU, and all of these computers were also designed to have, for their times, extraordinarily good graphical capabilities. They were more or less graphic workstations, but they were all incompatible with each other. Each of these companies was seeing the competition only as competition and nothing else. None of these companies was ready to partner and team up with another company to actually create a standard. Well, IBM also didn't, but fate made it a standard. If they would have teamed up and made a standard, the world would look entirely different. Because, as you see, the only survivor in this list is Apple. And that also was only by sheer luck. They had times when they were almost out of business, just like the others. Okay, so messages, open source for the win, of course. Yeah, our industry is unthinkable without open source. Be conscious about the purchasing decisions and make your organization aware if you find that the purchasing decisions of your organization do not match with the technical needs of getting your job for your team and for your client and for your customer done. For example, don't use ClearCase as a version control system. Yeah. Don't use Lotus Notes as an email client. The list could be endless. Okay, that's another famous quote from a German philosopher. Sorry that I don't come with Indian philosophers. I'm here for 3.5 years now. I've learned something about Indian philosophy, but not yet enough to actually fill my presentations with quotes from Indian philosophers. So act only according to that maxim, whereby you can, at the same time, will that it should become a universal law without contradiction. Now, that's, of course, very difficult to achieve, but I think it's worth at least trying to strive for. And I'm giving you an example from 1987 from Henry Spencer. He's a Unix programming guru, and he created the 10 commandments for C programmers. I just rushed through them. The details are not very important. So the first one is, thou shalt run lint frequently. What is lint? Static code analysis, yeah, code checker. Who of you is running something like lint in the project? Could also be checkstyle, PMD, find bugs, SonarCube, or anything. Hands up. Who runs it? That's good. Those that didn't raise hands, you know what you can improve. Yeah, I think it's really useful. Not everything is useful, yeah, but a lot of things are useful. Just you have to be a bit careful. I'm currently working in a project which is a Java project where there are lots of strict rules, and the rules are so strict that they actually prevent evolution. For example, the rule says you should not have empty statements, and the rule says you should not have any unreached labels in your Java code. Sounds reasonable until you try doing behavior-driven development in your unit tests. So be careful about rules. You have to know when times change and when you have to change the rules. Next one, thou shalt not follow the null pointer. Do you know where the null pointer is coming from? Those that have attended the functional talks, they know. So the null pointer is coming from Algol, and the inventor of the null pointer calls the null pointer invention his billion-dollar mistake. Now, my recommendation is, if you can choose, try to avoid null. For example, in Java 8, you could use optional, or better, try to use a programming language that doesn't offer null at all. Thou shalt study the libraries and strive not to reinvent them without cause. I think that's one of the things we get totally wrong in our industry these days. Because, for example, a few months back, I started working on a project. It had about 3,000 lines of code when I started. And so I cloned the Git repository. It was the first time I was using Gradle. I typed Gradle W tasks, and then for 20 minutes it was downloading jar files from the internet. I think what we are doing there is totally crazy. The size of our project is nuts. If we think that with 256 kilobytes of RAM in the 80s, people managed to run a multitasking operating system, several programs at the same time, and these programs some of them could do speech output. And then just look at the size of our JavaScript libraries that we're just using because we are too lazy to write get element by ID ourselves. Yeah, I've already seen situations where someone had the form with just one input field, and in order to get this input field done, yeah, let's use Angular for one field. Yeah, sometimes I have the feeling that some of us have forgotten how to write pure JavaScript. Remove jQuery, and they feel like they can't do anything. I mean, jQuery was very useful a few years ago, But the times of Internet Explorer 6 are over. Get element by ID works everywhere now. Yeah, so I think a lot of websites could load much faster than they actually do. And that has consequences. Thou shalt make thy program's purpose and structure clear. Yeah, that's, I think that doesn't need any discussion these days. Identifiers by the first 6 characters. We can be happy that this is no longer applicable to us. Also, it's actually no longer applicable to C programmers. Yeah, every C compiler that's relevant today will support at least 32 characters for the uniqueness of identifiers. Thou shalt forswear, renounce, and abjure the vile heresy which claimeth all the worlds of wax. Where's that coming from? It's coming from the 1980s, where the wax really was the most convenient and therefore most popular Unix workstation. But it had attributes regarding its hardware that were very different from other machines, which has led to the situation that when people wrote programs and didn't care about portability, they would not run on other machines. Sometimes they wouldn't compile, but most of the time they would compile happily, but then when you run them, at some point they would simply crash. I will take a very different approach to that. I'm very sad that it's not the case that all worlds Unix. When I look at automation, on Linux it runs fine, on BSD it runs fine, on macOS it runs fine. It's always Microsoft Windows that's causing me trouble. I hope Windows goes away and Microsoft creates their own Linux distribution, not just for the cloud, but spreads it to everywhere. Now let's talk about something serious. That's something to think about. We start our lives depending on software, and I think we should behave accordingly. That, of course, depends on what software you're programming, but you should be aware of what software you're programming and what depends on your software, whether it's a business or whether it's health or maybe even lives. And due to a bug in Toyota software, 89 people have been killed. At least 89, that was what was ruled by the jury and the judges in the court case in the United States. And it was a software bug. The microcontroller for the electronic throttle control system of the Toyota cars had not enough RAM. The stack was not big enough, and in a certain situation, the stack would overflow, override the RAM variables, and thereby change the bit of the variable that decides whether to slow down or accelerate. That caused unintended acceleration, and that has killed 89 people. And when these things happen, I think we should start to worry about how we deal with our craft and what responsibilities we have as engineers. A similar thing happened in the 80s with a medical device. Due to over-radiation, at least 5 patients were killed. We don't know how many patients were not directly killed, but died later because of over-radiation. That's difficult to track. And these are not the only instances, and I'm sure they are going to become more. And because of that, I think we need to develop a kind of a moral code, just like other professions have their moral codes. It's something that is not my idea, it's Robert C. Martin's idea, but I happily convey it further. And the reason why I think we should do so is, if we don't, sooner or later, something bad will happen. Sooner or later, software will kill more people than that. It's not the question if it happens. It's the question when it happens. And first of all, we should try to make that when as late as possible. And when it happens then, we should be able to say that we've developed software according to the highest standards of due diligence that we can do. And what we do today, I think, is far away from that. Yeah, when I look at the projects that I'm at, not everything is tested, although it's testable usually. Yeah, tests are often skipped. Architectures are compromised. So there's a long way to go. So we see how much we depend on technology these days. So the next slides will just come from mine. The killing people directly is not the only thing that we are getting wrong. If I look at how we waste CPU in many, many ways, like, for example, creating websites which do not use all the technologies that are there to actually cache and compress images and so on, we are wasting a lot of energy. Have you ever thought about how much energy we could save by just applying those efficiency technologies which are easy to apply? JPEGs don't always have to be 95% quality. 75% usually is sufficient, but very often, even 65 or 60% is enough. And then you can get file sizes down from like 180 or 320K to something like 20K or 10K. Yeah, you can use gzip encoding for HTML. You can configure your web server to tell the web browser how long to cache the content. And you can do the same for a good content delivery network. That would already save a lot of energy. For companies like Google or Facebook, it's rumored that the biggest expense is the electricity bill. For Google, I'm quite sure that this is the case. For Facebook, I've just heard the rumor. I've not yet spoken to Facebook employees about that. For Google, I know it firsthand. The electricity bill is the biggest expense. So pollution is something to worry about, not only when software is cheating. Yeah. So what Volkswagen did actually should have never happened. The IEEE actually has a kind of a moral code for software developers. And that software clearly violates the moral code that the IEEE has created for us. So, it's back. Very good. So this is a short version of the IEEE's code, but I don't want to run you through it. You can run through it yourselves offline. I don't completely agree with that moral code because it attempts to be a moral code similar to that of medics, but for medics, you usually don't hear about a duty towards the hospital. But every second paragraph in the moral code of the IEEE talks about the duty towards the employer, which I find for a moral code far too business-oriented. Of course, we have an obligation towards the employer, but I think the obligation to society, environment, and health, and things like that is much more important. So, one last thing about libraries. A few weeks ago, I was working in a project where the toolchain was set up and where I didn't know, can I just use normal Unix tools and things like that, so I asked around. I have an HTML page. It originally was a single page application. Now it's going to be multiple pages, just like 3 or 4. and I want the header and the footer to be the same. And my idea was to just include a file. And what should I use in that environment? And the suggestion that I got first from colleagues was use the Play framework. Do you know how big it is? The latest version is almost 80 megabytes. That shows how wasteful we deal with these things. I would have just called a C preprocessor. It's installed on every machine. Or used X-include, or maybe XSLT. Usually XSLT is also available on every machine without that you have to download it specifically. And since it was a Java project, XSLT is already there. If you have the virtual machine and the runtime environment, you have Zalan, and you have JAX-P. So why download 80 megabytes when you can do it with things that you already have on your machine? And the last thing I want to discuss is the programming languages. This is a picture of the Tower of Babel. It's a painting. If you look at the details, you know that these types of paintings are somehow silly. The Tower of Babel is rumored to have existed like 500 or 1000 before Christ, or even before that. And when you look at the ships are clearly much newer than that. The ships are looking like they're from 15-something. So the programming languages that we have, I think, are far too many. One of the reasons is they are owned by corporates, and I think we need to liberate our programming languages from the corporates. The best example is Java versus C#. It's basically, they are the same language. Why do we need two? Just because Sun and Microsoft don't like each other? And that influencing how an entire planet of software developers has to program? That is totally stupid, and that's one of the reasons why the aliens don't talk to us. Okay, so let's close with a quote from Henry Spencer. Those who do not understand Unix are condemned to reinvent it poorly. And that happens over and over again. The newest type of reinvention is called microservices. I call it pipe. Okay, thank you. Any questions?
You were talking about wastage of resources. Now, for your purpose, the use of Play framework was obviously a very bad choice. But in general, I think when we are getting better hardware, we optimize for developers' performance instead of machines. So it's not always bad to waste some resources, I think.
I wish I could agree. And for a long time, I thought the same way as you thought. And I thought it's good. But, for example, build systems. People created Ant because they were not happy with Make. But the reason why they were not happy with Make was actually not because of Make. It was because of the Java virtual machine. Because it takes so long to start. They have long forgotten the reason why they created Ant. When they then were unhappy with Ant and found out that they have to find a solution for Java's own DLL hell to manage the jar dependencies and jar versions, they created Maven. And then when they were not happy with the syntax of Maven and the lack of flexibility of Maven, they've created Gradle. The correct thing would have been to go back to Make. And when I just run Gradle help, it takes longer than Make takes for the same job to perform for the entire project. So compiling a project with Make is faster than just getting the help of Gradle. And writing Make files is not difficult. Actually, the syntax is so convenient, I'm convinced with our progress towards more declarative syntax, that in a few years down the line, someone will have a bright idea how to improve Gradle, and the result will look very, very similar to Make. So I wish I could agree. And certainly in several cases, you're right. But I think we don't look enough in the cases critically enough to see where we are wrong. Another example is Spring. Spring was set out to make J2E, to replace J2E with something simpler. The Spring projects that I see are no longer simpler than J2E. They're the opposite of that. Maybe I've seen the bad examples, I don't know. Yeah.
So more of a thought rather than a question, really. You mentioned a few things that we are unnecessarily creating CPU power, which we're probably not judiciously using. There are business interests where new hardware is thrown into the market every now and then just to create new demand. Same thing for software. And so from working in large organizations where you're more or less part of the larger picture, you can't really take these decisions. I'm just trying to voice an opinion here that sounds like a large-scale disruption is the only way to go forward with a combination of open source and freelance professionals. Is that how we're probably going to get to more responsible craftsmanship? It's probably the enterprise route sounds very, very tedious and too many factors in it.
I actually think it's neither nor what will bring us more responsibility. I think it's the end of Moore's law that is going to bring us more responsibility. We already see Moore's law slowing down. So the cycle that claimed to be 18 months but actually was 24 months no longer holds true. The gigahertz race has already ended 10 years ago. But the cores race also has somehow ended. We do not see AMD and Intel competing for cores. By the way, that's another example where we purchase wrongly. The 64-bit CPUs that we've created, that we are using, were created by AMD, but we are buying them from Intel. And a lack of competition is not helping the market, and it's also not helping ourselves. Right now, we are in a situation that really Intel CPUs have become better again because AMD was lacking the money for development. But I think it's the end of Moore's law that is going to drive more responsibility. I think for the next 2-3 years, it's still going to go a bit like today, and then we will see that actually we don't get more CPU, and if we want to run faster, we have to change the way how we develop software. And quantum computing is not going to save us. Quantum computing is not the near future. That's the far future.
Yeah? My question is, we have seen a lot of agile adoptions over the last 5 years, 7 years. But the craftsmanship is not quite spoken about. I mean, except maybe Robert Martin and his books, there's very less spoken about. You think the time is yet to come where it's going to be de facto, or how can we improve that in our environment, our culture?
Well, I think you don't need the word software craftsmanship in order to already follow some of its principles. First of all, I think there's a big overlap between software craftsmanship and agile. I think it's a logical consequence. And also, many people just don't know the term software craftsmanship. They know the term clean code instead. Yeah. But that's the same thing.
Even people are doing it, but it's like not consciously sometimes.
Yeah. Also, I mean, software craftsmanship is, you could also call it a refocus on the coding practices of extreme programming.
Okay.
Yeah. And so a lot of people are doing it already.